Lesson 6, this review, this is completely up to you if you want to do this on your own time. Just a review of inspection and a review of decomp. So you can do that. That's just an extra question if you want. So we're going to jump right into the next page here using this quad formula. So this formula here, it will be on your data sheet. You do not have to memorize it. Sure. Okay. So let's take a look. The very first equation they give us, let's make sure that we can identify these coefficients. In this case, A is 2, B is, and C is 5. Okay. That's very straightforward if it's written in the descending order. You know how it's like the squared term, then the x term, and then the constant? Sometimes they don't always be that nice. You have to like rearrange them to get them into this general form, and then it's really easy to spot A, B, and C. So it won't always be this easy. Keep that in mind. Okay. So let's take a look at their worked out solution. I'll use my pointer, so please follow along. The coefficient on the x squared is, B is, and C is. Okay, so now we're going to substitute into this formula. Is this supposed to be negative B out front? Okay, so here's the formula with a negative b. So if b is 7, then it's going to be a negative b, which is negative 7. It keeps negative, okay? Now in here, I'm going to actually, when we do this inside term, I'm going to teach you just to use your calculator, and it will come out perfect every single time. But the big idea here, so if you want to do this by hand, is you got to use brackets here. Because what would happen if b was negative and then you squared it? You'd have to go a negative times a negative, which is positive. But if you pump that into your calculator without a bracket, you're going to have issues. Okay? Okay? So we want to really limit our issues. Okay, so inside this radical, it's simplified to 121. Let me show you how simple that can be with the graphing calculator. So b squared, what was b? So b squared, and then minus 4 times, what was a? 1 times c. Negative 18. 121. Okay, so that expression, b squared minus 4ac, this thing right here, do that in the calculator. I don't recommend that you do it by hand. You could if you want. If you're skilled, then fine. But if you'd rather make your life easy, then use the calculator. And don't use the radical sign. Just figure out what the number is underneath. Does that make sense? Okay. The square root of 121 happens to be perfect because 11 times 11 is 121. Now you have negative 7 plus or minus 11 on top of 2. What that means is you're going to have to do 2 calculations, one of them with a minus and the other one with a plus. So the plus or minus means 2 calculations. So negative 7 minus 11 is negative 18. Negative 18 over 2 is negative 9. Negative 7 plus 11 is 4. 4 divided by 2 is 2. Okay, so let's try this one on the side. They're really giving us some structure here to help us. So A is 6. B is -1, and C is -12. So then we go to use this formula. It's negative B, so you have to put in -1, and there's also a negative on the outside. Plus or minus the square root of B squared, so -1 gets squared, minus 4 times 6 times -12, all over 2a, which is 2 times 6. Okay, with your calculator, simplify the radicand, the thing inside. So just simplify this in your calculator without the radical symbol. And watch when I use a bracket. -1 with a bracket squared minus 4 times a times c. So the bracket really only matters for the squared term, and you get 289. It won't always be perfect, and I'll show you what to do when that comes up. Oh boy. So you get x is +1 square root plus or minus 289 all over 12. So first and foremost, how did I get +1 out front? Double negative, right? And then the 289 we did in the calculator. You agree? And then 2 times 6 in the bottom is 12. Is the square root of 289 perfect? What is it? 17? Is it 17? Okay. So then our answer for x is 1 plus or minus 17 over 12. So we have two options. 1 plus 17 over 12 or 1 minus 17 over 12. One plus 17 over 12 is 18 over 12. 1 minus 17 is -16 over 12. Both of those can be reduced. Dividing by 2. No, dividing by 3. Common factor of 3, you get 6. Oh, there's a better common factor, isn't there? Divide both by 6, my bad. And you get 3 over 2. This one, what's the common factor? 4. Divide by 4, divide by 4. You get -4 over 3. So these are the two roots. You can call it x1, and you can call it x2. These are the two x-intercepts. So like this expression, pretty sure we could factor this expression. So we wouldn't have had to use the quadratic formula for this because the roots are actually rational, quite nice. But the whole reason we have the quadratic formula, typically, is when the expressions are not factorable. So we came across one of those one time in the quiz. The quadratic, you couldn't factor it. So for examples of quadratics you can't factor, then you want to use a quadratic formula. Guys good on this slide? Still need it? Okay, let's do class example 2. So I want you to take a look at the wording that they're using here. So the language that they're using, I want you to highlight this. Exact value, and then nearest hundredth. Okay, and the exact value has to be in the simplest form, so I'll explain that when it comes. So you have two things. Exact value, so for example, I'll use it on the whiteboard. There's square root 2, this is just a random example, versus 1.414. So hit square root 2 in your calculator. What? And the decimals keeps going, right? So if you had more screen, those decimals would just go on forever. Okay? Compare 1.414 to square root 2. Square root 2 is called exact, whereas this 1.414 is called approximate. Because one of them is a decimal that you have to round, the other one is exactly it. So when it asks for an exact value, you do not convert to decimal. This one wants both, and I'll explain to you when it shows up. Okay, so first things first, A is 2, B is -8, C is 5. Jot down the formula. Negative B plus minus square root B squared minus 4AC all over 2A. How do you feel about that? They are. It does look like that. But you'll never have to rearrange this. You always just plug into it. So there's no algebra with it. Okay, let's plug in what we know. What is the value of B? So you're going to go plug in a -8 for B. Notice you have a minus out front and a minus inside. Okay, now we do the plus or minus symbol. Okay, B squared. So when you substitute in this B, use a bracket. Minus 4 times A times C. And this square root symbol should hang all the way over all of those terms. And all of this stuff is on top of 2 times A, 2 times 2. So the front term and the bottom term are typically simple to arrive at. So on the front you have an 8, plus or minus. And on the bottom you have a 4. Now for whatever that junk is under that radical house, I would recommend the calculator. So we have a bracket, -8, a bracket squared. Minus 4 times 2 times 5. 24. So then we can replace all that nastiness with 24. Now, the square root of 24, go ahead and check that. The square root of 24 is irrational. In other words, it's not a perfect square. So then we have to use our skills from a previous unit. So we have 8 plus or minus all over 4. How can we simplify square root 24? What perfect square divides 24? 4. So I'm doing this on the whiteboard. Square root 24 is the same thing as square root 4 multiplied by square root 6. And the square root 4 is a perfect 2 root 6. So yes, this is a throwback to a previous unit. And it happens to be Thursday. So square root 24, we simplified here to 2 root 6. Now, do you remember with fractions, you always have to go to lowest terms with fractions? So here's just a random example, like 3 divided by 6. What fraction is that? 1 divided by 3 out of 6 is the lowest terms fraction, half, right? So we do the same idea with this. Except we can only reduce the whole numbers. We don't even try to include the 6. This, because it's inside of a radical house, it's sort of on its own. So how does the 8, the 2, and the 4 reduce? What do they all have a common factor of? So you can divide each one of those by 2. And you have 4 plus or minus 1 root 6. Do I have to write the 1? All over 2. And this is your final answer. And that's the expectation for the quad formula. It's not about the decimal that you get. Okay? So for 20-2 exam quadratic equations, you will have a general form given to you. You'll have to do quadratic formula. You'll be expected to plug it in. You'll get a radical you have to simplify. That radical needs to get put in lowest terms. This is the exact value. So this thing here, exact. Now, we have to do the nearest hundredth. So we have to do the approximation. So what are the two we have to calculate? We have to do 4 plus root 6 divided by 2, or 4 minus root 6 divided by 2. All right. And I'll just give you a second to copy, because then we're going to put this into the calculator. All right, 4 plus the square root of 6. You must hit enter first, then you divide by 2. So 3.22 is one of the answers. And the other answer will be 4 minus root 6. You must hit enter first, then you can divide by 2. 0.78. Why is that 0.78 and not 77? Okay, I'm still seeing, for a lot of you, this is like 16-year-old people, even older, still having trouble with rounding. Okay, so you be careful, especially in the numeric response. This is your last year where it ultimately doesn't matter, but next semester or whatever, you take Math 30 and you have a diploma. If you can't round properly, they're not even going to give you the mark. You do 5 minutes of this hard work, solve this crazy question, you get it right, but then you put 7.7 and you don't get the mark. That would be horrible. Make sure you round properly. Okay. So these are the two answers. 322 or 0.78. I mark by hand. I'm nice. The numeric response, it's like check, 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 check. Okay, so again, if you screw up this year, it's not the end of the world, but in the diploma, it will be. Okay, this one here, 4x squared minus 12x plus 9. They're giving us a grid, and I think they're trying to make us discover something here. So let's type in that equation into y equals. So go to y equals, and let's type this graph in. This is what you would have done last chapter. 4x squared minus 12x, and you have a plus 9. Okay? You hit, let's go zoom 6, make sure you're on the standard window. What happens here? It looks like it only touches once, hey? Let's really zoom in. Let's go -3 to 3. -3 to 3. Let's really zoom in. It's like you're going to pinch pull on your smartphone. We're going to zoom in. -3 to 3. -3 to 3 for x and y. What does it look like? Touches that graph only once. But the quadratic formula says it's giving us two answers. So what is happening with the algebra here? So we can sketch this in. Looks like it's touching once. So 1 x-intercept. Let's use that quadratic formula. So we got -b plus and minus b squared minus 4ac. You do this enough times, you'll probably memorize this thing. I like to write down the variables on the top just so we don't screw up. And I bet you're getting good at this now. So since b is negative, and then you go to put in -12, so you know this is going to be +12. And I'm going to highlight that for you. -12, -b comes out positive. Plus and minus. Okay, so now this b squared minus 4ac, getting good at this now. We can cheat a little bit. Go right here. Okay, what's b? -12. We're going to square that guy. Minus 4 times a times c. What just happened? The answer inside the radical is 0. So what happens to the quadratic formula when you plus or minus the square root of nothing? Square root of 0 is 0. So 12 plus or minus 0 is always going to be 12. 12 divided by 8 is, we already did this once before, divided by 4, you get 3 over 2, which is 1.5. And if you remember looking at our graphing calculator, It was exactly halfway between 1 and 2. So there's the 1.5 right there. And it only touches once. So here's 1, here's 2, there's 1.5. All right, let's do the next one. I'm going to type it right into the calculator, and I'm going to graph it. So it looks like we got a 2x squared minus a 5x and a plus 10. I go to graph this guy. My window is not good, so I'm going to hit zoom 6. Ooh, look at that. It didn't touch the x-axis at all. So how many x-intercepts do we have? We have none. Good. So I'm not going to sketch that perfectly. I'm just going to go like that. It's just sort of floating up in space up there. I'm going to jot that down. No x-intercept. And then I'm going to use the formula. Negative b square root b squared minus 4ac all over 2a. How you doing, sir? Okay. So let's take a look. What's a? B is, and c is, okay. So throw in what we know. We got a negative b, so we're going to come out with a positive 5. You guys are okay with that, right? Now that thing on the inside I'm going to leave for now. And then I got, what's on the bottom? 2 times a, so we got 2 times 2 is 4. So now on the inside here, the b squared minus 4ac. So b is negative 5. And I recommend that you always do it this way. B with a bracket minus 4 times a times c. What just happened? And it's not, the number itself is not such a big deal, but what do you notice about that? Can you square root a negative? This is why we get no solution, as you can't square root a negative. Okay, so no solution is equivalent to no x-intercepts. Yeah, you have to show that. All right, so before I let you go into work time, I want you to just scan this stop note. So scan the stop note. It says, in each case, the quad formula can only be used if the equation is in the general form. So skip ahead to question 7. And I'm going to put a hint. Rearrange into general first. Okay? So for 7a, what are you going to move? I would keep the 10t on the left and do what with the 7 and the 1? Yeah, move it all to the left. And for part B, same story. Because you'd want a positive. Excellent. Now the other part of the stop note. One more thing before it's time for work, guys. The graph of a quadratic function may have 2, 1, or no x-intercepts. So how do you know if that's going to be the case? If it's positive, you get 2. And what I'm talking about is that thing under the radical. If it's 0, you get 1. And if it's negative, you get none. Because the quadratic formula depends on this radical. And we know that radicals, if they're positive, you have an answer. If they're negative, there's no answer. Okay? And then there's this special case that if it's 0, then this whole plus or minus business doesn't matter anymore. If that second term is 0, you don't have to worry about plus or minus. So that's why there's only one answer. So 2 cases, or pardon me, 3 cases. Positive, you get 2 answers. Negative, you get none. And then the special case where you get the b squared minus 4ac is 0, you got 1 answer. Okay, so that's it. That's the last lesson.